once again, we are graphing a horizontal parabola uh, using properties. It's given in general form. Again, this is similar to our vertical parabolas where we have y equals ax squared plus bx plus c. Now we're just looking at x equals ay squared plus by plus c, and the right and left instead of up and down. So we're giving x equals negative y squared minus 4y plus 12. So let's look at our leading coefficient first. We know that a equals -1. And again, we're looking at the form x equals ay squared plus by plus c. So what that tells us is that because a is negative, we know the parabola opens to the left. Now let's look at the axis of symmetry. Now remember, our axis of symmetry, when we're looking at a vertical parabola, is going to be x equals negative b over 2a. When we're looking at a horizontal parabola, one that opens to the left in this case, we are looking at y, the horizontal line. Y equals negative b over 2a, which equals negative 4 over 2 times -1, which equals -2. So y equals -2 is our axis of symmetry. We'll go ahead and draw that in here. And again, it's not necessary, but it does help you to see what points you have due to symmetry when you graph intercepts or additional points. So now we're going to look at our vertex. Well, we know that the y-coordinate is going to be -2. So we substitute that, x equals -2 squared minus 4 times -2 plus 12. That equals -2 squared is 4, so -4 minus 4 times -2, that's minus -8, which is plus 8 plus 12, which equals 16. So our vertex is at 16, -2. So one thing we're going to have to do is we're going to have to make a scale of 2 in the x direction because of where we started with our graph, and 1 in the y direction. So we'd want to designate that in some way. And those little numbers right there would work as far as a free response question is considered in this course. So now that we have our axis of symmetry, our vertex, we know that it's opening to the left. Let's go ahead and graph our vertex. So 2, 4, 6, 8, 10, 12, 14, 16, -2. -2 is our vertex. We know it's opening to the left. So now let's go ahead and find any y-intercept. There should be 2, since it's opening to the left and it goes in the negative direction infinitely. So the y-intercept is when x equals 0. So we're going to have -y squared minus 4y plus 12 equals 0. Let's divide out that negative. Let's factor out the -1 or divide both sides by that -1 to get y squared plus 4y minus 12 equals 0. And now we want to try to factor. Are there any two numbers that will multiply to -12, but that will add to 4? Well, how about 6 and -2? So y minus 2 times y plus 6 equals 0. Let's multiply back through to make sure that works. Y times y is y squared. 6 times y is y. Minus 2 times y is minus 2y, so that leaves us with 4y. And then -2 times 6 is -12. So that means that y equals 2 or y equals -6. So our y-intercepts are going to be 0, 2, and 0, -6. So 0, 2, and 0, -1, -2, 3, -4, -5, -6. And if you'll notice, I made a mistake there. The scale in the vertical direction is simply 1. So I accidentally plotted that first point at 0, 1 instead of 0, 2. So let's go ahead and change that to 0, 2. And notice, I wouldn't have noticed that right off the bat had I not had this axis of symmetry drawn. That's why it can help to draw that axis of symmetry. I saw, wait a minute, this point is closer to the axis of symmetry than the other point on the other side of the axis of symmetry, which lets me see that I did something wrong, and then I can easily remedy it. So now we have our vertex, we have our y-intercept. We know it opens to y-intercepts. We know it opens to the left. Now, what about the x-intercept? That's when y equals 0. So the x-intercept, we don't have to write it all out because it's just 0 squared minus 4 times 0, which is just 0 minus 0 plus 12. So our x-intercept is going to be at 12, 0. So 2, 4, 6, 8, 10, 12, 0. And then that's 2 above the axis of symmetry. So we know there's going to be a point 2 below the axis of symmetry as well. So we also know that there's an additional point at 12, -4. And then we connect the dots for our horizontal parabola opening to the left. And if we wanted to check our curve, we could go ahead and check a few more inputs to verify that they do fall on the parabola that we drew for our graph.